All right, Algebra 1, we are going to finish up notes for Chapter 4 today. We are graphing systems of linear inequalities. So a linear inequality is written like almost like y equals mx plus b, but instead of an equal sign, we have an inequality sign, so the gator, right? And remember, the gator eats the greater thing. So we are going to graph these and then shade. So if we have this system, our first equation, which will be represented by the green arrows, is y is less than or equal to negative 2x minus 6. But when we graph this, we are going to graph it almost just like um, a normal line. So our y-intercept is negative 6, and our slope is down 2 and over 1. Or you could also think of it as up 2 and backwards 1, up 2 and backwards 1. So this is our first line right here. And the reason that it's a solid line is because it's a less than or equal to sign. When we have the solid line underneath, our line is solid. And then if we want it to be less than, the area that we would shade less than this line is underneath the line. So all the green arrows are pointing underneath. They're pointing less than the line. And then for our blue line, we have y is greater than or equal to x plus 4. So we have the y-intercept of 4, and our slope is up 1 over 1. Or you could go in reverse and go down 1, back 1. Y is greater than or equal to, so greater than is above. So all of our blue arrows are pointing above. Now the only place that we want to shade is where all the arrows are pointing together. So here there's just blue arrows, here there's just green arrows, and in this section the green and blue are pointing towards each other. So we would shade right here on Savas. In our next example, we have y is less than 2x minus 1 in green, and y is less than or equal to x plus 3 in blue. So in our green line, our y-intercept is negative 1, and our slope is up 2 over 1. And it's a dotted line because it is less than and not equal to. So we have a dotted line right here with the slope of 2. And then it's less than, so our arrows are pointing below, right? And then for our second line, we have y is less than or equal to x plus 3. Our y-intercept is 3, and our slope is 1, so up 1 over 1, or down 1, left 1, whatever way you think about it. And our blue arrows are less than, so they're also going down, and our line was solid because it's less than or equal to, right? We can be equal to that line. So in this skinny area right here, we only have blue arrows. In this skinny area over here, we only have green arrows. But in this big area over here, we have blue arrows and green arrows pointing towards each other. So we would shade in this region. Lastly, we have a system of 3 linear equations. But this one is not written like y equals mx plus b, how we like. That's how we want to graph it. So let's kind of play around with it. If we start with negative 2x minus y is greater than or equal to 6, we want to get the y by itself. Same idea as like 4.1, where we solve for y. So let's move the x over. Let's add 2x to both sides. So now we have the negative y is greater than or equal to 2x plus 6, and I put the x first because we want the x to come first, just like y equals mx plus b. And then we still have that negative 1 in front of the y, so let's divide everything by 1. If you divide something by 1 or something, you have to divide everything. So we have to do it to all 3 terms. And remember, when we have inequalities and we divide by a negative, you have to flip the sign. So now instead of greater than or equal to, we have y is less than or equal to negative 2x minus 6. We can graph something like that. And then these over here are just lines. That one would be going straight across. This one is going straight up and down. And let's graph the green line first. So our y-intercept of negative 6 and our slope of down 2 over 1, or up 2 and left 1, right? So it's a solid line because it could be equal to. Obviously, that's not straight, but you get the idea. And it is less than, so all the green arrows are going below the line. And then our blue line, y is greater than negative 2. On the y-axis, let's go to negative 2, and we're just going to go straight across. It's a dotted line, and the blue arrows are pointing up because we are greater than. And then x is greater than or equal to -6. So on the x-axis, we go to -6, and that line is straight up and down. And greater than or equal to, that means a solid line, and the arrows are pointing right. So we got a ton of different arrows, a ton of different colors. But the only region where the arrows are all pointing towards each other, green, purple, and blue, is this triangle right here. So we would shade in that area. This is a lot. If you have any questions, concerns, feel free to reach out and we can walk through some problems.